Wow, 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 wow. My goodness. There's so many of you. Thank you. Thank you. There's so very, very many of you and so few of me. I'm overwhelmed. I can't tell you how thrilled I am to do Socrates in the City in Houston. We have done it in other, backwater. There's no way, once you use the adjective backwater, there's no way to redeem it. No, we've done these events not just around the country here and there, but also in the south of France, in Oxford, England. If you go to the website Socrates in the City, you'll see those. But we love doing them in places other than New York. Usually fewer stabbing incidents. Not that I'm not here to judge, okay? I'm just saying. But we really have never done one here. And I've been to Houston many times, and I know I've met many of you in my various visits to Houston, but it just thrills me that we're doing this here. I apologize for the club. It's the best we could do. Is Dick here? Where's Dick? No, we are so thrilled that we could do it here. Now, if you're unfamiliar with Socrates in the City, let me say, get out. I can't believe you would show up here having no idea what you've stumbled into. But it's your own fault because you are now part of a UFO cult. And the mothership's going to come from behind a cloud in about an hour, and we're all going back to our system, our star system. I hope you don't mind because you're in. No, actually, what Socrates in the City is, some of you are familiar with the concept. Socrates said, the unexamined life is not worth living. And then he blew his brains out in an alley. That's not true. That's not true. He said the unexamined life is not worth living. And I, about 22 years ago, thought, you know what? Most of us are living rather unexamined lives. Wouldn't it be a nice thing to have a forum where I could have conversations with people about what we call the big questions? Sometimes we say life, God, and other small topics. And over the years, we have done that. We've asked big questions. We always try to ask a question, right? Tonight, we're asking the question, I forgot, what was it? Something along the lines of, how did life begin? Where did life come from, right? That's a kind of a big question, isn't it? So we've asked the big questions. Who are we? Where are we going? What's the capital of North Dakota? The stuff that really gets you. My favorite question is, are you going to finish that burger, honey? And of course, the follow-up, what about the fries? I say honey because I'm currently married to my current wife. Today is our 26th wedding anniversary. Yes. And don't applaud. We're just through the first 26 years. But I think we're going to make it. You know what I'm saying? I think we're going to make it. Suzanne knows me at my very worst, and for that, I resent her. But I also know her at her worst. And so, we've got this stuff on each other. It's just such a crazy thing that it happened to be our 26th wedding anniversary tonight. But we really have together been through thick and thin, and also through greasy and stringy. I don't know if that's, because it's been rough. It's, thick and thin, what does that mean? But the secret to our success in marriage, and I don't mind saying this publicly, we have an open marriage. I have, from the beginning, remained open to the idea that Suzanne's relatives could have me killed if I looked at another woman, in the wrong way. And I've been open to that idea all these years, that it could all end with a blunt instrument if I'm out of line. And that has really worked for us. And the most amazing thing I just want to say is that, when I say 26 years of marriage, I should be really clear. Since I'll be talking to a scientist tonight, I want to be accurate. 26 years, I'm talking consecutive years. Do you understand what I'm saying? If you're a math person, we're not skipping around, okay? This is one after the other, with no exceptions. 26 years today, and let me say to Suzanne, baby, you're the greatest. And she really is. I'm not just saying that, she really is. Socrates in the City is about, when Socrates said that, it's not just that he said the unexamined life is not worth living. He also was always in pursuit of the truth. In other words, he had this idea, as most Greeks like myself do, that philosophizing is worth doing. It's worth thinking about things. But he was kind of relentless, and he got in trouble for seeking the truth, as you inevitably will, because we live in this fallen world. Correct me if I'm wrong, but they killed Jesus. Yeah, and Socrates actually was also killed. And Diogenes, he was searching for an honest man. He was killed in a knife fight in downtown Athens. And yeah, you can laugh at that one, that's not true. But the point is that when we're talking about truth, you realize how serious it is, because oftentimes when you pursue the truth, whether in science, as we'll find tonight, or in other things, there are people who don't like it. And I find that idea itself fascinating. So maybe we'll talk about that. I want to tell you how I came to know Dr. Tour, which really led me to write my book, Is Atheism Dead? It's kind of crazy. It was about 4 years ago. We have a dear friend, Elizabeth Blakemore, who's right here, sitting next to my current wife of 26 years. And Elizabeth invited me to a dinner to meet a nano-scientist named Dr. James Tour. And of course, being Greek, I know the prefix nano means 1 billion. It means really, really, really super tiny, right? And I confess that when I met him, I was surprised that he was about my size. And I thought, I don't understand, and as I spoke to him, I understand that it was nanoscience really has nothing to do with the size of the scientist. I realized that. But he of course, is a super genius. I'll read some of his credits in a minute. And I find it ironic that our friend Elizabeth introduced us, because Elizabeth, kind of dull. She's got as we like to say, splinters in the windmills of her mind. Is that not true, Elizabeth? 3 bricks shy of a full load. How can I put it? How can I put it kindly? Her pilot light blew out. That's how you know you're my friend, if I make fun of you in public, okay? That's my love language. That's my love language. But it really, in all seriousness, that evening I just thought, I'm just going to a dinner. And I met Dr. Tour and we got into a conversation, and somehow he starts talking about the concept of how life began, not what happens once you have life, because you can get into all kinds of arguments and conversations about the concept of you have life and then it evolves in this direction, or God directs it, or whatever. There's all these conversations about intelligence and science, but he wasn't talking about that. He was talking about the concept of you have no life and then suddenly bing, you have life. And we're going to talk about that tonight, because when I heard him talk about it at that dinner, I said, you know what? No one ever talks about this. And this is really as seminal as it gets. When you talk about what are the big questions in life, how did life begin? Not human life, how did life begin? So it's a fundamental question. And so I got excited about it, and I talked to Dr. Tour more and more and more about it. And of course, I said, listen, this is so exciting, you need to write a book about it. But Dr. Tour is too busy doing actual science and writing peer-reviewed papers to waste his time writing some crappy book, which I'm personally insulted by that, because I'm an author. And so I thought to myself, the more I learned about what he was doing, the more I thought, maybe I need to write about this. And so I did. There are 2 or 3 chapters in my book, Is Atheism Dead?, where I talk about this issue, because it really is an extraordinary concept. And once I realized the depth of it, the more I thought, we've just got to kind of tell the world what Dr. Tour knows about this. Now, I say I put it in my book. I stole everything, of course, from Dr. Tour and other scientists. I don't know that much about chemistry. I think I got as far as 11th grade chemistry. I did for a season. I knew Avogadro's number. I never met Avogadro, but I knew his number. I spoke with him on the phone, and then of course, like an idiot, I lost Avogadro's number, and we haven't spoken since. And I feel what a fool I've been, because he's a pretty important guy. I remember once in 11th grade calculating molality. Does anybody remember that? Yeah. I remember there was a brief moment where I understood molality, and then I forgot all about it. I believe I once dated a lipid. I'm not sure. I don't know if that makes any sense. But I'm not exactly a chemist, so everything in my book, obviously, I take from Dr. Tour. To tell you a little bit about Dr. Tour, officially, and this is the least interesting, he's the T.T. and W.F. Chao Professor of Chemistry at Rice University. He's also Professor of Material Science and Nanoengineering. But I found an article, some of you are familiar with George Gilder, the economist and genius in his own right. And I thought if I read this to you, it'll give you some sense of whom I have the privilege to converse with this evening. So this is from the George Gilder report. He writes, just over a year ago, the world changed. History turned a corner. A new age dawned. So far, few have noticed. In due course of time, history will record that the new age was midwifed in the laboratory of Dr. James Tour, Professor of Chemistry, Material Science, and Nanoengineering at Rice University, a chemist with some 700 scholarly papers. If you understand what that means, your mind is blown. And 150 patent families to his credit. Tour, George Gilder writes, is a modern-day Isaac Newton. Now, if you know who George Gilder is, you don't take that lightly. He is leading a scientific revolution at the smallest of scales with deep roots in chemistry and physics and grounded in carbon, the most fundamental life-giving element in the universe. Tour is ranked today in a drastic underestimate as one of the top 50 most influential scientists in the world. He will soon prove to be the most influential. His innovations promise to defeat deadly viruses and superbugs, overcome cancers and genetic disorders such as Down syndrome, displace ineffective diagnostic technology, heal severed spinal cords, we'll talk about that, clean dirty air and water, trivialize excessive CO2, obviate all convention trash disposal, render rare earth materials abundant, retrieve unrecovered heavy materials, replace existing electrical wires with fabrics 1 million times as conductive, revolutionize construction materials, boost battery performance, eliminate toxic organics, re-energize depleted soil, banish rust, and in a wonderful parallel to Newton's demonstration of gold's immutability, end counterfeiting of both your Gucci purse and its contents. Ladies and gentlemen, Dr. James Tour. Thank you. He's really here. He's really here. Dr. Tour, I'm so thrilled finally to get this chance to talk to you about some things that are really hard to process. I think I want to start maybe with the evening that my former friend Elizabeth Blakemore introduced us. I'll never forget how you started in on me on this issue of the origin of life. It seemed like you had a bee in your bonnet. In fact, anybody who watches your videos knows you have many bees in your bonnet. And that's why I love you. You're delightful to listen to. But do you, I mean, I want to talk to you about nanoscience, but can you just give us just a taste before we get into it of what you say to a stranger like me on the issue of the origin of life?
Well, I don't even remember our conversation.
Well, you don't have to remember the conversation. I don't remember the conversation. Actually, I remember not being that impressed with you. No, but what I'm saying is that you kind of gave me the rundown of Miller-Urey and what we know today. Can you give us the paragraph version before we get into the deeper stuff?
We're clueless on the origin of life. We don't know how to make the basic 4 classes of molecules that are needed for life. People have never made them in a prebiotically relevant manner, which means that using chemistry that would have been available on an early Earth when you didn't have all the big machines that we have now, how you could ever make those 4 classes of molecules.
Okay, in a spirit-filled church, I would say, and now can we get the interpretation?
I thought I was...
No, I know you were dumbing it down for us groundlings, but not low enough, not low enough. Let me, I think that's why I'm here. I realize there's a reason I'm here. I guess, before we get into that, because that's the real subject of our conversation, I want to talk to you initially about what you do as a nano-scientist. I heard about your work, I guess maybe 15 years ago through some potential investors. They were talking about nanotechnology and some of what you were doing. When I just read what George Gilder wrote about you, we're talking about really astonishing things. We know science has done astonishing things, but you now are doing some things in that world. Maybe talk just about the nanocars, because that struck my that struck.
Sure, these are single molecule nanocars. They have 4 wheels, independently rotating axles. They have a motor. You shine a light on it.
Hold on. You see, you already lost them. Trust me. We're talking about a single molecule. This man makes molecules in lab. But I mean, most of us don't make molecules like at the office, right? So why don't we, before we get into that, maybe explain the idea of when you say you make molecules, we know you don't have incredibly tiny tweezers. So can you help people understand you make molecules in the lab? Molecules, they're pretty small. So is there a way you can help us understand how you do this or how you got into this?
What you do is you make Avogadro's number at a time. You do 6 times 10 to the 23rd at a time. You just swallowed 10 to the 18th molecules of water, at least.
I can tell.
Yes.
I can tell. But it tastes like 10 to the 17th.
So what I'm saying is that when you do this, we work with molecules in mass. Just like when you drink water, you don't just drink 1 molecule of water, you drink many, many of them. And so what we do is we do chemistry on groups of molecules that are in a round bottom flask, and there's solutions in there, and we add different reagents, and then their structures change based on the reagents that we add. Their structures change. And we plan this out, and then whatever doesn't make what we want, we separate out, and we take it and we go to the next step.
But again, to be clear, when we're talking about nanotechnology, you cannot see can you see a single molecule?
You can see a single molecule by scanning tunneling microscopy, or AFM, you can, but that's not how you do chemistry.
AFM, yeah.
Atomic force microscopy, you can.
Okay, so you can see, because
But you don't do chemistry on 1 at a time, or else it'd take a long time to get a bunch done.
All right, so we're not going to make that mistake. Suzanne, make a note of that. We're not going to, we don't want to screw that up at home. But what you did was in other words, it's conceivable maybe that you can make molecules or manipulate molecules, but you made molecules where each molecule, I know, look, you did this 14, 15, 16 years ago, this is like no big deal to you. But you made molecules that each molecule is a car.
Yes.
So let's go back to that. Describe molecules that are effectively cars. You were able to do this.
Yes. So each molecule, it's one molecule. They're very small. You can part 50,000 of them across the diameter of a human hair.
50,000 of them
On the diameter.
side to side,
Yes.
parked, since they're cars.
Yes.
50,000 of them across the diameter of a human hair.
Yes.
Okay, so they're that small,
Yes.
but you were able to manipulate things so that they function as cars. How do you mean that?
Okay, so they all have 4 wheels. They all have 4 axles. They have a chassis. And on that chassis is a motor.
Okay, what kind of a motor?
It
I mean,
is-
what do you mean on that
There's a
chassis
motor.
there's a motor?
It is light activated. You shine a light and the motor spins at 3 million rotations per second.
And what is the motor comprised of?
Carbon, hydrogen, and sulfur.
Is there a glove box? No?
We can put one in.
A
if
teeny
you'd like.
weeny, a teeny weeny.
We could.
Anyway, I just wanted to give you all a sense. I mean, so imagine a single molecule that has 4 wheels and it's one molecule,
One
and you're
molecule.
telling me it's so small that it can fit across, that 50,000 of them would fit across a human hair. So that's the scale at which you are working.
Yes.
Keep it simple, yes or no answers will do. So what are some of the other things? Tell us about graphene, because in the article by George Gilder, he talks about this recent development where you can make graphene very inexpensively, which is going to revolutionize our lives.
Yes. So graphene is a single atomic sheet of graphite. Graphite is a chunk of material that's made up of sheets. If you take off one of those sheets, it is graphene. Graphene is 1 atom thick. It's a sheet of carbon atoms that are arranged like chicken wire. 6-member
1
ring.
atom thick.
Yes.
That's extraordinary.
Yeah, and so, but this material, when you put it into other things, it, strengthens the other materials a lot. So you can put 0.01% into concrete, and you can use 30% less concrete, just by putting in a very small amount of this material, for example. And that's a big deal from an energy saving side. To use 30% yet less, because concrete is 8% of all CO2 emissions in the world come from the making of concrete. And what we'd like to do actually is replace concrete so that, because concrete's been around for 2,500 years, and I think it's time it got retired. And we can use another material which would be much lighter weight and equal in strength or stronger. And then we can also just modify the material and use it for an airplane fuselage. It's all made out of carbon, these sheets of graphene. That's the hope. That's the hope. We're not there yet. But
Yeah.
that's what it's projected toward. But it's not far from some of those applications.
Right. Well, you and I also, we met subsequently in New York City at the 2nd Avenue Deli, which is not on 2nd Avenue. It's so famous that they moved it, but they still call it the 2nd Avenue Deli. And you and I met there with
the folks
Mitch.
from Chosen People Ministry, and my son.
Mitch Glazer. And we had matzo ball soup. You're Jewish, I understand.
Yes, but I had a salad.
All of my... all right. But while we were there, you pulled out your phone and you showed me a video of I was trying to eat my food, and you showed me a video of a white rat. Can you describe that and the technology, the graphene technology?
Yeah, so that was with graphene nano ribbons of graphene, not individual square or cylindrical sheets, but ribbons. And so what was done with the rat, and I told you earlier why the whole process behind this, why we were going down that line, but the spinal cord was completely severed in two with a scalpel, and then we put one...
At the T5.
Yeah, C5.
At the C5.
Yeah, C5.
Did I mispronounce C?
Yeah, because if you said T, I thought.
Oh, so you did this intentionally to...
How'd you remember that?
To sever, what?
How'd you remember that?
I don't know, it's in my book. You intend, I just want folks to track with what you showed me on the phone while I was trying to eat my soup. You, in a lab, intentionally severed the spinal cord of the rat, which would paralyze it, right?
Yes.
Okay. And then with nano ribbon, with these graphene ribbons.
A 1% solution of graphene nanoribbons in another polymer. We put that in the gap. And then what you do with the gap is you just open it and close it. So you got the spinal cord's been cut in two, and now you open it and close it. Just by doing that, just by that action, it gives you something called shear flow, where these long, thin structures of the graphene nanoribbons will organize longitudinally, they'll organize in line with that spinal cord. It's like logs in a lake, and don't interrupt me, let me finish this. They understand logs in a lake. When it goes down a river, the logs start orienting with the flow of the river. That's called shear flow. They all organize with the shear. So just by opening and closing, it organizes in line with the spinal cord. And then I don't do the work. I mean, the people in the lab stitch the head back, allow the spinal cord to reheal, and then it takes off from there.
Okay, but the point, of course, is that because of the nature of graphene,
yes,
it provides a kind of armature over which the nerves that have been severed can regrow together.
Exactly, because what happens is they will normally grow, but then they miss each other. As they're growing, there's nothing to line them up, and they pass like ships in the night, and that's it. So what happens is these act as avenues upon which the neurons like to grow. They like to grow on graphene because graphene is conductive, and they're sending out electrical signals, so they enjoy growing on graphene. And so they're growing from each side, and all of a sudden they now collide. And when they collide, they refuse, and then they heal. That's it.
So the idea is that with this technology, you will eventually be able to do something, virtually unthinkable, is that people who have been paralyzed because their spinal cords have been severed, this technology makes it possible to heal those folks.
Well, that's certainly the hope, because you never got to the key point that after 2 weeks, the rat got up and started walking around. You forgot that part. And then after 3 weeks...
I was trying not to interrupt and thought you would get to it.
After 3 weeks, it started running. And so the first 2 weeks, the rat just was sitting on the bottom of the cage, moving in sort of a scattered sort of way, but the brain was remapping the connections because the connections were not the same as they had been originally. So just like a child has to, you give a child the food, they stick it in their ear originally. But as they learn where to put that food. And the rat had to remap the connections, and the brain has the plasticity to remap the connections. Once it remapped, and it learned which leg was which, and then it can get up and just start walking again. So the hope is that injured spinal cords could be healed with a technology like this. It's not there yet, but that's the hope.
But you did it with the rat.
Correct.
Previously when people talk about somebody having their spinal cord severed, there's no way to get the nerves to grow back. This makes that a possibility.
Correct.
I'm not overstating the case.
No. You're not overstating the case.
You also said that, if somebody has their optic nerve detached, they're instantly blind because optic nerves can't grow back. They can't be reattached. You, I believe, said that this graphene, these nanoribbons could also help with that.
Well, yes, I had a student working in a lab in Colorado with an expert that's working on whole eye transplant. So the idea is if you have a whole eye transplant, you have to join the optic nerve. The person has an optic nerve coming from their brain, and the other side is to the eye. So you've got to cut at that point, at some point along that, and reconnect the optic nerve. And so the idea would be to have optic nerve reconnection through these as well.
And that's never been done.
That's never been done.
So
it would be a big deal.
He's a real showman, isn't he? I just love the understated way you say it would be a big deal. The blind will see, It's going to happen. This is big stuff. It's big stuff. I just wanted to give people a taste of some of the stuff you're working in. It's really amazing, and I just encourage you to look up Dr. Tour, and you can read about all this stuff.
We have a TikTok video coming out of that rat walking again, actually. It's just about to come out. So.
A TikTok video?
Yes.
Don't applaud. I'm disgusted. So what really, the reason I ended up writing my book, Is Atheism Dead, is because when we had that conversation about the origin of life, I was so astonished, I thought, nobody talks about this. So let's talk about this. You, in the restaurant in Houston.
New York.
No. This is when we were with my former friend, Elizabeth Blakemore.
Oh, okay.
You started explaining to me, because I think all of us in high school were forced, it was on the test. It was always on the test. How did life begin? So what is the standard model since 1952 when people say, to high school students, to college students, how life began? What do they say?
It's not only the standard model to high school students, it's the standard model to college students, it's the standard model to graduate students. It's in all of their textbooks, and from middle school through graduate school. And it is the primordial soup model. There is a pond, there's a body of water, and there are molecules in that body of water. There are some lightning strikes, and the molecules start coming together, and then they assemble into cells. Those cells start coming together, and you get little creatures that start swimming around in that pond. And then those creatures end up coming out of the pond and start populating the earth. That's the primordial soup model. That's what's taught.
But I remember the night we were talking about it, part of my astonishment was the fact that I haven't thought about this. Because as I said, we all argue, or many people argue about evolution and all that kind of stuff, but nobody ever talks about how you get life from non-life. It's one thing to talk about, we have some life, and how can it modify? How can it change? How does that happen? How do you go from a single cell to a lizard? But to talk about there's no life and then suddenly there's life. So scientists today would say life appeared 4 billion years ago. We know that.
Yes, it appeared immediately after the cooling of the earth. When I say immediately, sub 100 million, maybe 50 million years, which on a geological timescale is very, very rapidly. There's evidence for life immediately upon the cooling of the earth after the heavy bombardment, when the earth was pelted with many meteorites that actually filled our surface of our planet with many different elements.
So scientists, when you ask them how life began, they will tell you, yes, we know it began 4 billion years ago. Exactly, single-celled life appeared. So you can agree with that, but then you say, right, it appeared. How did that happen? And you say that, I mean, at the end of the day, they always point us back to this 1952 experiment. And I remember you telling me that it's been 70 years since that experiment. And they were so hopeful. They thought, we produced amino acids, we're on our way.
Do they know what amino acids are? I mean, you're throwing out chemical names here.
Yeah. Let me just say stuff. The building blocks of protein. But I remember you explaining this to me, and I remember thinking, you know what? I never think about this. So you said that in those 70 years, the assumption was that they created amino acids, and then that they would then be able to do the next step and the next step and the next step, and they would begin to eventually figure out how you get single-celled life. Yes. And so it's been 70 years. How are they doing on that? Not
very well. Nobody has ever made a cell. Nobody has ever, so you get amino acids. It was an amazing experiment. So set up an experiment with a flask with very simple compounds, ammonia, carbon dioxide, nitrogen, and oxygen, and you start putting in voltage pulses to simulate lightning strikes, and you get amino acids formed. These amino acids were not handed. They did not have optical activity, meaning that our hands are non-superimposable mirror images. If I put my right hand up to a mirror, I would see an image of my left hand. That's why my right hand does not fit into a left-handed glove properly. They are non-superimposable mirror images. You cannot insert one into the other. The vast majority of molecules are like that in biological systems. They had they had both molecules mixed together. How you got one, which is what you need for life, nobody knew. But at that time, they didn't know that you really had to have only the one hand and not the other. So even Miller and Urey thought it was going to come very quickly, and then they've confessed it really didn't come very quickly. I mean, this is...
It never came.
Never came. Not only, I mean, we're so far from that it's become harder to get than it was in 1952. It's become harder.
See, that's the key.
Yes, that's the key.
Is that you said, I remember you saying to me, and I find this all funny, actually. This is like so delightful to me, that they're all excited because the idea is that science, if they remove the God hypothesis, they would say single-celled life emerged by itself through random processes. And in 1952, they were able to create some amino acids, and they just thought, we've got it, we're on our way. But what you're saying is that the more time passed, they were not able to move the ball forward. In fact, you said it's like they moved the ball backwards. The more you learn, the more you realize we're not doing this.
So the goalpost got further away, because what happens is the cell doesn't change, but we understand more about the complexity of the cell. And all of a sudden we're like, oh, I'm gonna have to build that too? Oh, I will have to build that too. So the complexity, as we learn it, you're like, this is crazy. So the ball hasn't moved backward, but the goalpost has moved further away. And so we're much further from the target than we were, from the goalpost than we were in 1952, because of the things that we have learned, which are amazing, just amazing. And so how does a cell do this if we can't make a single cell? The cell does this because it takes all of this information. When a cell divides, it splits it between its two sides, and then it pinches down in the middle. And so it keeps spreading this. We have no idea how to do that. No idea.
But it's been 70 years.
70 years.
They've been working on this hard. And you're telling me that, I mean, there's two pieces of information here. A, you're telling me they've been working on this puzzle of how you get life from non-life. They've been working on it hard, day and night, for 70 years. Okay.
It actually even predated that. That was the big experiment that they thought they were right on the verge.
That was like the kickoff.
Yes.
That they thought, we're on our way now.
Yeah.
But what you're saying is that the more we learn about the details of what's required to create the simplest life imaginable, which is a single cell, the more we've discovered how complex the cell is. So that's why you're saying the goalpost is moving away. The ball is still here, but the goalpost is like flying across the universe.
Yes, yes, it's moving much faster than the ball is moving forward. The ball makes nanometer increments as it goes forward.
Well, okay, but so then this brings up the biggest question. I mean, you describe this in detail. You've got lots of videos. By the way, you have a YouTube channel.
Dr. James Tour.
Dr. James Tour. Okay, because there are going to be people watching this who really want to get into this. And you do get into this. But what's so fascinating to me, what really kills me, is that you know this world of nanoscience. And you know that they've been working on this 70 years. And you know that not only haven't they moved the ball forward, but the goalposts are like speeding away. And you're calling them on it. In other words, you are saying, excuse me, I know what you know, and I know what you don't know, and I know you're blowing smoke because you have gone after some of these folks because they're making claims that we've pretty much got this figured out, and you're saying no.
I'm saying no. And it's bothering the community. And
What community? What community?
The origin of life community. There are researchers.
There's a community?
Yes. There's researchers that work in this area of origin of life, and they have meetings together, and they discuss the progress. And it doesn't go anywhere. Can you imagine doing that for 40-year career, and you're further away from the goal than when you started 40 years ago? And so they keep saying that we're going to have life in, Lee Cronin said it in 2011, that he'll hopefully make life in his lab within 2 years.
He said this in 2011?
2011. He was not successful.
Just doing the math, I'm thinking maybe that didn't happen.
Jack Szostak at Harvard, a Nobel Prize winner, said in 2014 he'd have life in his lab made within 3 to 5 years. He missed that date.
But you see, again, you're so understated. I know from what little I have watched of your videos at Dr. James Tour on YouTube, that it would be like saying, I'm going to have a car in 2 years, right? And then you find out that I don't even have any idea how to make a wheel or a motor. In other words, to make a claim about a car when you don't know how to make a motor, or you don't even have the beginnings of knowing how to make a single piston, how would you dare to talk about a car?
Right, it's even more than that, Eric. It's in the 1500s saying, I will be on the moon in 2 years. We've not gotten flight. We've not gotten space travel. We have no idea. There's no infrastructure for that. And if you had said that in 1500, you would get locked up. And that's what it's like. We can't make the 4 basic classes of chemicals. I'm not going to say their name. The 4 basic classes of chemicals.
Oh, just for laughs. Tell us what are the 4 basic classes of chemicals.
One is the young lady that you dated, lipids.
Lipids? All right. I said I think I dated a lipid. I can't say for sure.
Another is carbohydrates, which are your potatoes, but they're a very important class of compounds. Those are the hardest ones to make. Another one is the amino acids and the proteins that are formed from amino acids, and the other are the nucleic acids, which are the DNA and the RNA, which are actually a sugar, a carbohydrate with a base on it, and a phosphate group. And so those are the 4 classes of molecules that we need. We can't even make those in a prebiotically relevant manner. And any papers that publish and say we've made it in a prebiotically relevant manner are absolute junk and nonsense. And that's what I am exposing. And of course, it bothers the community.
We don't want to bother the community. But again, I find this funny because as I've watched your videos, it's so obvious that they're not even, to say somebody's not close, it's all degrees and it's all subjective. I mean, they're not in the same galaxy. Like we're talking about something, when you talk about what the simplest life is, it's a level of complexity that is like almost incomprehensible, and they're still claiming that it came together by itself through random sloshing in the prebiotic soup, and you're calling on that.
Yeah. So people have computed, because they'll keep saying cells were much simpler back then than they are now.
Before the war.
Before the
war. Yeah, everything was much simpler back then.
Yeah, okay.
But I mean,
yeah.
How simple...
I didn't know that one.
How simple, when somebody says, because I want to be clear that I, until I started looking into your stuff, when you think of what is a cell, it's a membrane and there's a nucleus, so it's like a jelly donut. I mean, how complex could it be? What is it? But the more you look into it, the more you realize, oh my goodness.
It's a factory.
It is an entire...
It's a factory.
It's like a universe of complexity.
Yes. It's like flying over New York City at 30,000 feet and thinking, oh, that's interesting. Or going down on the street and seeing the infrastructure, and then under the streets and seeing the infrastructure, and everywhere you look, there's this complexity that you never saw at 30,000 feet.
So in the early part of the 20th century, we couldn't see much of that complexity.
It was just a bunch of protoplasm.
Okay.
Very easy.
Which is like a made-up word, like jelly donut.
In the beginning of the 20th century.
In the beginning of the 20th century,
yes.
And so that kind of gave people hope, like, well, we'll figure this out.
Right.
And then they begin discovering what is in the nucleus and what is a membrane. I mean, a membrane, even that word, you think, okay, membrane. Well, talk about the complexity of what is a membrane.
So it's a bilayer membrane. What you have is you have two layers. And what's happened is the two layers are different. The outer membrane, which is the world in which it sees, is different than the inner membrane, where the nucleus and the endoplasmic reticulum and all this DNA is working, is different. And so every quote-unquote protocell that people have made, they say, well, this is the beginnings of a cell. They've never had the inside different than the outside, so all their protocells are a bunch of nonsense. They could never work. There's a reason for that, because you have to have what's called a proton gradient. I'm not going to explain it, okay? You don't have.
I'm not going to ask you to explain it.
Yeah. So it's because the hydrogen atoms that have lost an electron are called a proton, and they can move in and out, but they stay on one side more than the other because the two sides are different. If the two sides are the same, you don't get that gradient. All their protocells are a bunch of garbage. There are experts in origin of life that say it's just like making salad dressing, which is crazy, which is absolutely crazy, because you have these little bubbles in salad dressing. First of all, those are not vesicles where you have an inner and an outer layer and a middle, but there are ways to make vesicles, but it could never work. What you've made and you've called even your membrane, without even worrying about the stuff in it, it could never work. That's just the membrane layer. Then you have all the stuff in it. People will say, all you need is a piece of RNA. That's a bunch of nonsense. It's been calculated all the different things you need to have a cell to work. Not only have they not made all of those things, they haven't even made one of them. It's a list of about 25 things. They haven't even made one of them. Not even one.
Okay, but they're still asking us to believe that a lifeless universe, through random sloshing, made every single one of these things, and then assembled every single one of these things in this exquisite order that eventually ends up being what we call life. And let's be honest, like, we can't even define what life is, correct?
That's correct. So if you have a cell that just dies, we're just talking about a little cell, a yeast cell, a very simple cell, not even a human cell, it's a very simple cell, just dies. Ask a scientist, what is it that we just lost? What is it that we just lost? I did this experiment once. I don't know if my daughter will remember. I had a bunch of scientists over for dinner, and I said, watch this. I said, I have a cell. It just died. What is it that we just lost? One guy said, it's the ionic potentials. The other says, no, it's lost much more than ionic potential. They could not even agree on what it was that we just lost, let alone how you define life. You can talk about the characteristics of life, you can specify, but what is the life? What is it that you just lost? Scientists can't even define that, let alone make it. And that's why I say that even if I gave you a cell, that just died, go ahead, bring it back to life.
In other words, you're saying if a cell dies, every single one of the parts is there.
Is there.
In other words, I'll give you that.
Yeah.
Now make them work.
Yes, because a resurrection should be easier than a bottom-up synthesis. You know, everything's there. All the parts are kind of in place. Now bring it back to life. Can anybody do that? There's not a scientist in their right mind who will say that they can do that. Even origin of life people would never say that they can do that. They won't say they can't do it because they won't admit it, but they'll just look at you. That's what they do. They just look at you. They say, can you do it? They just look at me.
By not answering you, they're obviously saying something.
Yes. I mean, I saw Steve Benner at a meeting in Israel.
You saw Steve Benner?
Yes.
Who's Steve Benner?
Steve Benner is a big origin of life researcher. And he was asked, okay, say you had all these pieces, could you assemble a cell? He said, well, you know, a career is 80 years. I'm 3.5 score into this. One of these other people will do it. Like, what kind of answer is that? What kind of answer is that?
That's called kicking the can down the road.
Yeah, so the next day I challenged him on this. No, he just stared at me. They can't do it.
Can you imitate him?
I'm the crazy one that's bucking against scientific consensus? I'm the one who's nefarious, I'm told. They tell me I'm nefarious.
Nefarious?
Yes, which means
You're
evil
nefarious.
and wicked.
Really?
Yes.
Can you define wicked and evil?
No, because I looked it up because I want to see what are they actually calling it.
Right. Well, but I mean, again, I find the whole thing funny. The idea that you're showing very clearly. I mean, to people who are in this world, to most of us, it wouldn't make sense. But you're showing them clearly how they have nothing. You know, it's like Houdini showing, you know, the trick of the guy at the seance or whatever. He's exposing, you're exposing, and you're infuriating them because they have entire careers and lives based on the fact that this is a thing, and you're saying, no, it's not a thing, and I can prove it's not a thing. And so how is that going at this point? Like, I mean, even I have watched enough of your stuff to know that these people know they're in big trouble.
Well, you know, as you've seen my videos, I get very excited about this. But to tell you the truth, it's the most irksome work that I've ever done.
The most irksome?
Irksome.
Can you define irksome?
Detestable.
Irksomeness. Detestable. So,
because...
Yeah. Go ahead.
Because I'm telling people who have spent 40 years working on a project saying it's a bunch of nonsense. I'm telling them this. And I'm presenting them with their own data and showing them how this could never work. And I can feel their pain. I can feel their pain.
I can't feel their pain. I mean, of course, I know what you mean, but there's something here. The reason I find this so fascinating and in some ways humorous is because these are the very people who ought to know better. In other words, you can fool us. We don't know enough to know whether you're blowing smoke, but they in that world have to know. So it's kind of like a con game, or it's kind of like a pyramid scheme, and like we're all in on it, and nobody nobody let the outsiders know that we know that we're kidding ourselves.
Right. And this is the thing, that the common person cannot know this. You take their word for it. So when Steve Benner publishes a paper on a bunch of junk that he's made that he called RNA, but it's not RNA because it's not assembled properly and it has branches and all these things. And it could never work. And he says, this simple model explains and forms the basis behind Darwinian evolution. I mean, he just said this a couple of months ago to the press.
That's like a leap. That's like a insane
huge leap. That means you made a cell. That cell is passing on traits to offspring, and away you go. So what happens is when any chemist sees the presentation where I present these people's data, they see it. It's obvious to them that this is smoke and mirrors, that this is a game, that there's nothing behind it. And it's embarrassing to these people. It's embarrassing, and I feel their pain. And look, I'm a Christian, so I feel the pain of others that some other people give it to them. I mean, I feel the pain. So, but it hurts me to do it, but I'm exposing this because what happens is, as you've seen in my videos, is the whole world is misled. 2/3 of the general population thinks that scientists have made simple organisms like a bacterium in the lab. 1/3 of the general population thinks that scientists have made living creatures like frogs in the laboratory. And this is so far from the truth, but this is what you get. And 80% of those people that were interviewed, that were in this survey, had college degrees.
Okay, so this is, I mean, again, this is what kicked off my interest in this. Is in our initial conversation, I thought, part of what's fascinating is that no one ever talks about this. Nobody ever thinks about this. There are all these debates about evolution, but the idea, we all kind of skate past the idea of life. Like, well, we assume life. And you're saying clearly that not only is it conceivable that life created itself, because there's nothing to do anything. It's like we're talking about inert stuff.
Inconceivable,
right?
Yeah.
And you're saying that we know that, but it really, to me, there's something grotesque about people devoting their lives to science who are being dishonest about this. This is what I find so horrifying about it. In other words, you're saying that they've been telling this story so that most college graduates in America believe that we got that covered. And you're saying not only don't we have it covered, we're not even close. We're not even. We don't even have the beginnings of an idea. The more we know, we know nothing about how life emerged 4 billion years ago.
That's exactly right, because even if you could make all the 4 classes of chemicals, and you can't, in a prebiotically relevant manner, even if you could make them, you don't know how to polymerize them, build them into the higher structures, and then assemble them into the workings of a cell. We have no idea. And none of these men and women that work in that area would say that they could do that. Yet they make these projections of having life, and it is frustrating, and that's, I guess, become my mission, to just talk about this.
And how has it become your mission? Because, I mean, again, part of me is horrified at the scientific community or the community, the origin of life community, that they themselves wouldn't be more forthcoming about this, because it's kind of black and white. This is not, you know, when we look at your presentations and things, it's clear that they're blowing smoke, they're making claims, they're making leaps and things, and we're talking about science.
Yes. You know, some of them are beginning to come forward. There's a gentleman named Clement Reichert in Germany. His group, he's written papers that, hey guys, you know, we can't keep doing this very elaborate chemistry and saying that happened in a puddle like this. You've got to have hands-off approaches. And people from his group contact me and say, we watch all of your stuff. These are groups doing origin of life, and they say, we think you're right. So they're working in this area, and they think I'm right. And I think what's happening is it's getting to the graduate students. The graduate students are the ones that are starting their careers in this area of origin of life. The older folks are already committed. They've already thrown their hat into the ring. After 40 years of working on this, you can't say, whoops, I'm further away than when we started because the cell, we recognized all of these new complexities to a cell. But I think it's getting to the young people. And the young people are the ones that are watching this, that are saying, why am I doing this? Why am I doing this? Now, I'm not against origin of life research. I think it should happen, but totally different than what we're doing now. And there are ways to totally shake up the way research is done, and that's what I think we need. Because if any of the established researchers says, hey, I've been doing this for 30 years and I'm further away than I ever was, who's going to fund that? Who's going to give you more money?
But is that the issue? The money?
Money's issue? Yeah. I mean, money's an issue for research. You don't have money, you can't fund your lab, and you can't fund your lab, you're not an important scientist anymore. You just go teach a few undergraduate classes.
So it's not about, what a horror. It's just dismaying. And again, I write about this in my book, but the idea is that most of us here, we have a high view of science and therefore a somewhat high view of scientists, believing that it is about evidence. It is about the facts. It is about logic. It is about rationality. But when we're talking about this kind of thing, it seems to be about money and power. It doesn't seem to be about those things.
Yeah, you can go further with this than I feel comfortable going further with this, because I don't feel comfortable putting upon them what they might be doing. But you are right in the sense that the public is so utterly confused on this issue, and this is a big issue. This is a big philosophical issue. Where did life come from? And when you say, you've got it, you'll have it in the lab for 3 to 5 years, and the two people I mentioned are not the only people that have thrown out numbers like this that have all blown by. And that's why I keep saying all of those origin of life researchers will die of old age before they solve this. And all of their students will die of old age before this thing gets solved, because I know we're so far away. And it is upsetting to the public. It's upsetting to students. I gave a talk recently at Rice University on this subject, and that's on the YouTube channel there. And one student asked, so what about science, where you make a hypothesis, you investigate this, and you find out that your hypothesis is not right, and you modify your hypothesis, this way that we sort of portray to students the way science is done. Well, it turns out that science isn't always done that way. Science is controlled by powerful people, by powerful interest groups, by people who hold the purse strings. And powerful people can keep saying, let's do this, and it pushes these things along, even though it goes against what the hypothesis is seeming to tell us.
Well, you see this over and over, right? I mean, my discussion with you about the origin of life and Miller-Urey and all that kind of kicked off my wanting to think about this and writing this book. But the same thing you see with the Big Bang hypothesis. I mean, there were people just kicking and screaming against the evidence. It was bothersome to them, the idea that the universe emerged literally out of nothing 13.8 billion years ago. It was somehow repulsive. I mean, it was repulsive to Einstein. And it's normal, it seems to me, for people to like some ideas and dislike some ideas. But when you're talking about scientists, you really expect the scientific community to just deal with the facts.
I wish it were that way.
Well, right. But it's kind of, it's dramatic to me.
Yeah,
because
and yes, it is dramatic. This is just one point where facts, in my view, are not being followed, and I'm exposing it. And now, it does not take a genius to expose this. If you are an organic chemist, this is obvious. So any time before I will release a video series on this topic, I have it vetted by colleagues of mine. And I'll watch the series. Did I get any of the science wrong? And once in a while they'll say, well, you said nucleotide when you should have been nucleoside, so I'll put a little banner thing, nucleoside. But none of the content was wrong. All of them said the content was correct. And in fact, what they said is, I can tell you what one of them said to me. He says he thinks that these people working in the area of origin of life should be fired. They should lose their positions. Because then it became obvious to him. He said, well, why didn't he know this already? Because nobody reads origin of life papers except people working in origin of life, and then they go out and they tell the press. And you say, well, why don't you read papers on it? Because nobody cares. You think it's already done, it's already solved. And the other thing is you have a busy life. I read a lot of papers about nanotechnology. I'm not going to read about origin of life. I'm only reading about it now because I have to go after it. So you don't really scrutinize it, and you don't know this even by just reading their paper. You have to go into the experimental details. So you have to, online, you have to click on the experimental details, and you go and you see how they ran the experiments, and you look at the actual data, and you say, my goodness, this is garbage. This is just garbage. Here, look at this spectrum. This is nonsense.
What got you started? Because you're, as we said in the beginning, you're doing really amazing work. So what got you, in a way, sidetracked onto this? What was it that got you involved in exposing this?
So in around 2000, 2001, I got sent a statement, and I don't even remember who sent it to me. It was from the Discovery Institute. I didn't even know who they were at the time, but it was a statement that said something to the effect that we are skeptical that random mutation and natural selection can account for the diversity of life. Therefore, further research is warranted. That's it, further research. And they said, could you agree with that? I typed, yes, boom, return. That's it, I forgot about it. I find my name on a list of 700 scientists that have signed on to this. That list was then used in the Dover trials when people were trying to bring creationism into public schools. That's when that list became popular, and it was called the Descent from Darwinism list, and I'm on that list. I'm not ashamed.
D-I-S-S-E-N-T.
Yes, not
dissent, not
yes,
dissent.
not
right.
Not genealogical descent. So I find myself on this list, and I'm not ashamed of it in the sense that I agree with that list. And why people would ever be upset with that statement, I don't know. I don't know why they'd be upset with that statement, because it just says further research is warranted. This is what we as scientists do all the time. Further research is always warranted, or you get no more money. Hey, I've solved this one, send me no more money, I'm good, whatever. Never, never. So why would you say it here? Why would you be upset that somebody says we need to research this further? So
okay, now clearly this has nothing to do
with
origin of life. But
right.
So in 2000 or around that time,
yes.
You get this email saying, would you agree
yes.
that random, what's the sentence?
Random mutation and natural selection.
That it's not quite, it's not open and shut. Further research is required. You, being a genuine scientist, say obviously correct, because you know that it's true.
Yeah.
And saying yes got you in trouble with who?
With my colleagues who felt that I should not be put forward. I'd already had tenure, I already had a chaired professorship, which means that some rich family in town helps to boost up my salary. So I had already had a chair. Chair doesn't mean chair.
Right.
You wanted me to define everything tonight.
Not a literal chair.
Yeah.
All right, I can get that, okay.
Okay, so they said they would not put me up for awards because I'd signed that statement. And I was like, what statement?
Who said they wouldn't put you up for the award?
My colleagues.
Okay, your colleagues were so angry that you had signed that, that statement.
I didn't know that they were so angry until that point.
Okay, and when that happened, that kind of set you off.
Yes, I said, I was minding my own business, guys, but if that's the bottom line, you know as well as I do, we don't know what's going on in this evolution thing when you look at the chemistry involved in what's going on here. And if you take a chemist and you challenge them on this, do you understand the chemistry behind these steps on how you're going to get these massive changes? You know what they say? They just look at you. Nothing, no response. And you know you got it. So I said, I'm going to start looking at this. And then I met David Berlinski. He said, why don't you start looking into this and write an article? And
he put you up to this.
Yes. And so I wanted to trace back evolution to back, see exactly what are the theories on this. And that's how I got into origin of life. I didn't even know what abiogenesis was. That wasn't my area. And then all of a sudden I thought, this is crazy. I started asking my colleagues, where did life come from? And they said, a foremost reaction. And so I started looking up the foremost reaction in this work by Eschenmoser. So I looked up Eschenmoser's work, and I thought, this is a bunch of nonsense. Eschenmoser's a great chemist. I've admired him a long time. But this work is nonsense to project this on life. And then every paper I started looking at, it was every stone. It's like, wow. And that's when I started. I wrote an article for David, and he published that. And then people started putting it in books, and the same article, they'd reproduce it and put it in books, and then they'd ask me to write another, and somebody would publish a paper making great claims, and they'd say, can you critique this? And I'd say, oh, this is going to be easy. I'd tear that apart, write an article on it, and that'd get published. And then I thought, nobody's reading the articles. Who reads articles? So I got to, let me talk about this on YouTube. And that's when I got invited to Dallas. You and I were in Dallas 3 years ago, and I gave that talk in Dallas, and they put it up on YouTube, and it exploded. It exploded. I even got a call from the guy at Harvard who I called out. He said, you were pretty hard on me. And actually, he sent me an email, and because I called him a liar, and I regretted that. And he said, you're pretty hard on me. I said, I apologize for calling you a liar because I don't want to get into the ad hominem attacks. And so I said, can I talk to you on the phone because I want to apologize to you, at least over the phone. And he was very gracious. He forgave me, and we had a discussion. And I said, how come you think you're so close? He says, well, we have this. I said, I don't see. He says, Jim, if you would join us in this research, we'll solve this thing. If you just join us. It's hard for me to join you when I don't think you're going down the right way. And so anyway, that's what kicked it off. And then I thought, by YouTube, I'm hitting the masses. I don't need to hit my colleagues anymore because they're not interested in this. And the people in Origin of Life they don't read my articles. They don't want to read it. But I'm hitting the masses, the very people that are being affected by the press because of these people's comments. I'm going to go after the masses. So if you would just please go and subscribe to Dr. James Tour on YouTube, it will really help to drive and click a thumbs up on these videos, because these algorithms then just take over and the thing just goes. So
you might
do
get
that.
canceled. Honestly, though, this is so it really was. I guess you felt an injustice had been done against you because you signed this thing as a scientist, and people basically said, "We're going to punish you for this."
This was an early form of canceling. Yes.
Well, yeah, and they basically said that you're not playing nice, and we're going to make you pay for having dared to lend your august name and credentials to these maniacs who would dare question blind Darwinism, and that got you angry enough to start digging in.
And it didn't stop there. So I have been approached by two different federal agencies that give grants. Both times the people were in my office and told me this. They said, you can stop writing proposals to this agency because you're never going to get funded. They were my friends. They were just telling me you're wasting your time. I would be asked by a program director to write a proposal. I'd send it in. He'd say, great, scored great and everything. Boom, it wouldn't get funded. I'd call him. I'd say, it didn't get funded. And he'd be shocked. Somewhere above them, it was not being funded. Somewhere above them. And so two different friends of mine from federal agencies told me that I was not getting funded. So they tried to cut off my lifeblood. You know, to a researcher, this is what we live on. This is like, you know, somebody burns down your factory. I mean, this is it. But the Lord took care of me.
But it is interesting to me that you wanted to reach what you call the masses. It's not really the masses that are interested in this chemistry, but there are people, obviously, many people that are interested in this, and you decided it's worth going over the heads of the elite gatekeepers who don't like this stuff and who will not allow you to speak, in a sense.
Yeah, because I felt if I don't do it, who will? I already have tenure. My kids are grown and on their own. I mean, they're fending for themselves. That day comes, and they pay for themselves. I don't have to pay for their education anymore. If I don't do this, who will? I mean, it would be much more threatening to a young professor to say what I'm saying. I mean, they even come up to me. They say, I agree with all your videos. Don't use my name. And I understand that. I understand it, and I appreciate their telling me this. Why do they want to subject themselves to this kind of nonsense? And so if I don't do this, then who will?
I don't know, I was thinking of taking a crack at it. Well, it is, I'm very glad that you've started putting this stuff out because what we're talking about here, I mean, this is kind of like the opposite side of talking about making graphene inexpensively, and it's going to lead to a revolution. This, too, will lead to a revolution. In other words, if graphic students in the privacy of their own homes watching these videos, grad students, see what you're putting out there, I mean, I just have to say that, you know, the elephant in the room is what Stephen Meyer calls the God hypothesis. That it's hard to get away from the idea that if it's so just almost unbelievably difficult to begin to move in the direction of life, that a lot of people are going to conclude maybe God did it. I mean, most people would have to at least consider the concept of that. Now, as a scientist, you can't say that, but the point is, that strikes me as why this is so difficult, because a lot of the scientific community has become wedded to a materialist, scientistic view, and that even suggesting that something can't happen through natural processes is so offensive they have to cancel you.
Yes, and so this is the God of the gaps hypothesis. What we can't explain, God has done. And I've been accused of that many times. That's why I never bring that in. I never say, well, we can't explain this, so it must have been God. No way. I could never say that as a scientist. What I actually say is that I presume that in the future we will learn how life formed. And that may be 500 years, that may be 1,000 years, but I presume that we will learn, because that's all that I can say as a scientist. Just like a person in the year 1500, if you said, well, when are we going to have space flight? I mean, how could they even make a guess? I know it's not going to be soon. So that's all that I can say. And it is a basic fundamental when we start thinking about life, just how you define what it is I just lost. Not even in a creature as complex as a human being, where you have this whole other dimension of consciousness and thought, but even of a cell. What is it that I just lost when that cell died? And you're scratching your head. It was just alive. Everything's about in place. You know, something like poke it or something. What did I just lose here?
And you can't say a soul because we're talking about single
He's
cells.
talking about a single cell. I don't know. Do single cells have souls? I mean, they might.
I don't know.
You know, I mean, you know, you got to, you start from one cell. I mean, and the thing divides and divides and
Well, what's funny is people
know.
will use phrases. It's kind of like protoplasm. They'll make up a phrase like "élan vital." You know, they'll talk about some life force, and you know, it's like a 1940s or 50s science fiction film, the life force. And you think, well, what is the life force, and where does it come from? And you know, and that's what we're talking about. I mean, look, nothing could be more appropriate to ask at Socrates and City is, you know, what is life? That's what we're talking about. What is life? Where did it come from? And then what can we know about it? Even if we don't have an answer, what can we know? And it sounds like, you know, look, all of these scientists have been learning things over these 70 years. They've not been doing nothing.
I think that what we've learned is that we have absolutely no idea, and everything we've tried is an utter failure. That's what we've learned.
Right.
Yeah.
But that's not nothing, right?
Yeah, that's not nothing.
It's
This thing is a whole lot more complex than what we thought.
Right. That's an understatement. I mean, that's a dramatic understatement. But the point is that if you're honest, you would say that's not nothing. You know, that's something. But if you've already pre-established a goal that's getting funded, and it's not in line with learning that we know nothing, then you have a problem, as some of these folks in the community seem to have. Well, okay, so you're on YouTube now. You're putting this stuff out there. How long have you been putting these things out there, and where do you think this might go?
Well, over COVID, because I wasn't traveling as much, I did a 13-part series on origin of life. And
So COVID was bad for the community.
for the origin of life community, it was really bad.
Very bad.
I had a lot more time on my hands.
Oh, that's very bad.
And so,
Very bad.
and it was like 13 or 14 different parts, but now I have the click once. You can just click and listen for 9 hours straight. So if you're ever suffering from insomnia, just click and you'll be okay. But I explain the problems with origin of life from the beginning. Now I'm coming out. And this came because somebody attacked me. I was minding my own business, and he came out with a video, and he says, Jim Tour is clueless on this, and here's how life formed. And it was so ridiculous that I had to come out. It took me 9 hours of video to show how wrong this person was, because a lie is very easy. To tell the truth and to explain it is really detailed. Then he came out with a 2-part video saying I had it all wrong again. So now I'm coming out with 2 series on this. The first series is just about to come out, and it's on the experts. So he brought on some so-called experts. He brought on 3 experts. 2 of them knew that they were being brought on. One of them didn't even know it. He just took one of the guy's videos and stuck it in as if he was, and I know this because that so-called expert is a friend of mine, and told me, he said, what do you mean I'm on a video? And he had no idea. So anyway, all of that will be exposed, but now I can go after the quote-unquote scientific experts and their data. They came after me. They said things about me in a social medium. I'm going to use a social medium to just put it right back at them. So
They
now,
pushed you too far.
Pardon?
I think they made a real mistake when they decided
Yeah, they made a real
tangle-
mistake. And what I said, whoever goes on this guy's YouTube channel and talks about origin of life, I'm going to go right after your work. I'm going right after your work. And every paper that he cites, I will go right after that paper. These origin of life people are going to hope that this guy never uses their papers in his evidence for origin of life, because I'm going right at, so this is what I'm doing, and it really is the best medium. It is the best. It gets out. You get thousands and thousands of views so quickly, and it's an amazing medium, and you hit large numbers of people all over the world, and so it has a real impact. You know, I write all these articles, nobody ever reads them. I have 700 articles nobody's ever read.
Well, right. In all seriousness, I mean, what started this off for me and made me write my book was was the same impulse that people need to know. The world needs to know what you've been sharing tonight and what you've shared with me, because it doesn't get more fundamental than this. When you think about questions, you know, we're not, you know, talking about how did the moon form or how to, you know, that's fascinating, but it could not be more central than how did life come into being, and then to discover that the people telling us how are blowing smoke, know that they're blowing smoke, and that it can rather easily be shown. That's headline news. That's a big deal.
That's a big deal. And people will say, well, maybe aliens brought it to planet Earth, and I'm fine with that. That could be. But we're not talking about that. We're talking about origin of first life. Where did those aliens come from? How did their life be made? So
let's see their papers.
Yeah. I'm sorry, going after them. Yeah. So it's origin of first life. You know, we can't just, because that's what many people do.
We're not dumb enough to buy the aliens thing. You don't need to explain that to us. You know, when people say,
I thought this is what this meeting was about. Yeah. We're all going to be.
Yeah. No, but I mean, it's funny because in my book I refer to who was it? Watson. It was either Watson or Crick.
Watson. This is the panspermia model.
Yeah. No, but even that, the term panspermia, like you give it this fancy scientific name. It's like it's the stupidest thing ever. It's like, how did life come to Earth? From someplace else. And they go, really? Yes, I call it panspermia. And you think, well, that really, that's like saying, who baked that cake? Where did that cake come from? Who made that cake? And you say, well, no one here made it. I believe somebody carried it down the hall from over there someplace. And you go, okay. Can we go there and find out how they made the cake? Because we don't really care how it got here. We care how it got made. And so the idea that Nobel Prize winners would float these ideas like panspermia, it seems like you're making it up, like a joke, actually. It seems amazing to me. And so my impulse, as I say, in writing about it, and I'm so glad you're making these videos, is that the world needs to know this. This is not a little thing. This is a big deal thing. And I just want to say on behalf of Socrates in the City and the innumerable people who will watch this and your videos at Dr. James Tour on YouTube.
Dr. James Tour.
Dr. James Tour. I want to say thank you, Dr. James Tour, for being